Doppler class number 2. In Doppler we use two modes, spectral Doppler and color Doppler. But in spectral Doppler we use a screen called duplex. It's the combination of B mode and spectral Doppler. B mode is the superior area of the screen. It's exactly a B mode. Spectral Doppler is the information of the velocity of the blood and is a time in the horizontal line and velocity in the vertical line. Time, velocity. This is a spectral mode and the system is called duplex. You have here B mode and spectral Doppler. In this picture we have the same, but also we have color Doppler in the B mode. That helps to know where is the area that you are going exactly to measure, because color Doppler put color in the area where blood is moving. Spectral analysis is the mathematical that the machine produces. It's a very complex mathematical, not important for us in this moment. This is how the machine produce or process the information. Spectral analysis. In the screen of the spectral Doppler we have three different things: the time that is in the horizontal line, the blood velocity that is in the vertical, and the amplitude is the bright of the signal. You can change all three: time, amplitude, and velocity. Horizontal, time; vertical, velocity; and the bright is the amplitude, the strength of the signal. You can change the time. That not mean that you change the velocity. That means that you present the information in different velocities. In general we use always the same. Only sometimes we change when we want to get more details, but it's very rare. You also can change the scale. That means when the wave is too big or too little, you make a better presentation. That not change the velocity of the blood, it's only the presentation. You put bigger or little the wave, but the scale will be the same. You can change the amplitude. You have a button to make the gain. Exactly at the overall gain, you put more bright or less bright. Don't put too much bright because you can erase details of the wave. This is the shape of a spectral arterial wave. In the vertical we have the frequency of the Doppler shift or the velocity of the blood. In the horizontal you have the time. One part of the time is systole, when the heart contracts and the blood moves. The other is the diastole, that is when the heart relaxes. The fifth part is the peak systolic, is the part where velocity is faster, occur in systole. Of the contrary, other important is the end diastolic, because it's the part when the blood is going slow. Is the last part before the new systole. Other areas are window, that is inside and in a normal condition must be black. The envelope is the area where blood is moving. The carotid notch is when systole finish and aortic valve close. And all these things can help doctor to make diagnosis about arterial disease that is in general stenosis of the arteries, plaques, atheromas that close the inside of the arteries. This is a schema of the carotid arteries. The inferior part is the common carotid artery, in the right side coming from the brachiocephalic trunk, in the left side coming from the aortic arch, that divide into arteries: the external carotid artery that give blood to the face, and the internal carotid artery that give blood to the brain. Little below the internal carotid artery are the carotid bulb, a region of the artery delayed, and there are produced a lot of turbulence. This is the area where are more common plaques. Here we are going to study a normal display of external carotid artery. This is called high resistance flow. External carotid artery is peaky and also have other very important characteristics. The flow in the diastole, in other words, the end diastolic flow is very low, sometimes near zero. This is the characteristic of external carotid artery: peaky and low end diastolic flow. This is how you see really in the screen an external carotid artery spectral Doppler. The internal carotid artery wave is very different. It's round, it's not peaky, and have a high diastolic flow. That is because external carotid artery are low resistance artery. Brain always need blood, a difference of muscle, and this is for that there are a lot of flow in the end diastolic area of the wave. Internal carotid artery, high flow in end diastolic area. This is how look the internal carotid artery in the screen. High flow in the end diastolic and is round. The other important artery is the common carotid artery. As common carotid artery divide in the internal carotid artery and external carotid artery, common carotid artery is the combination of characteristics of both. Is peaky as external carotid artery, but have a high blood diastolic flow as internal carotid artery. It's the combination of both internal and external carotid artery. You can see here end diastolic flow is high, but is peaky as external carotid artery. Common carotid artery is a combination of the both artery that divide the common carotid artery. This is how look the common carotid artery